Friends, in this class we are going to learn few more points regarding to our electrical engineering drawing. Mainly in this class we are going to concentrate on DC and AC windings. DC and AC windings. Okay, so that means if you observe here, what are this one? So this is the one armature, you can see. This is the one armature, this is also one armature, and this is also armature, this is all armatures, and this is also armature. These all are wound with copper windings. So these windings wound for different applications for the different machines for AC as well as the DC. Depending upon our requirement and applications, whether you are going to give the AC supply or DC supply, or for the both AC and DC, just like universal motors, how we are going to wound the armature windings. Okay, so in this class we are going to concentrate to develop how the DC windings and AC windings developed in our practical electrical field. DC and AC windings. I have the one doubt. Here already you learned that. So the winding in case of transformer, last class we have seen. For example, you take the transformer, single phase transformer, and here winding is wound on primary and secondary side. When supply is given to the primary, it induces a EMF in the secondary. Okay, but in this case, as we know that there is no mechanical torque is developed in the transformer, or if you are taking the three-phase transformer also in DTRs, generally you can observe in nearby street. So this is the R phase, Y phase, B phase for the 11 kV input, whereas the secondary and is connected to the 400 volts. So whenever the three-phase supply is given to here, but there is no mechanical movement any part inside the transformer. But whereas in just we have seen a DC or AC motors, when supply is given to this machine, the rotor will rotate in a nearby synchronous speed. Same three-phase winding, R phase, Y phase, B phase winding. In transformer also we provided, so R phase, Y phase and B phase windings, but here there is a mechanical energy developed in the motors, but in this case no mechanical energy developed. Why? Same three-phase supply given to the motor and same three-phase supply is given to the transformer. It will give the electrical energy output, but why can't it develop its mechanical movements inside, but it is developed the movement. In rotor it induces a EMF. Okay, so a secondary induces a EMF, but in addition to the EMF it develops mechanical energy output. Here only electrical energy is the output in case of the transformer. Why? What is the reason behind this one? Okay, so in this class we are going to learn this thing. because in transformer the winding in transformer winding is concentrated winding. That means in limb we are going to wound in concentration, just is the concentration, whereas in motors, in machines, you can take that whether it may be generator or motor, the winding is distributed. That is not concentrated one way, it is a distributed in a slots. Hence here the mechanical energy is developed, whereas there is no mechanical energy is developed. That means these windings are concentrated, where these windings are displaced 120 degrees apart. So 120 degrees apart for each phase. So that is the distributed winding. Hence here the mechanical energy is developed in case of motor, and if the electrical energy is given, and it develops the mechanical energy. If the mechanical energy is given, it gives the electrical energy. Okay, so this is the main reason. Let us see these motors in big industries, how they are worked. You can see here. Motors in industrial revolution, all machines are nowadays using with help of small fraction of kilowatts to some the hundreds of kilowatts machines. How they are worked and how they are used in industries. For example, we take in our electrical industry itself. You can see this is a yoke of the big machines. Now it is a movement from the horizontal, vertical, different places. So we are using our motors for lifting, momenting, everything. So how we are going to get these mechanical movements? Okay, you can see this one. Every movement is required some mechanical movements. So this is our yoke of induction motors. Lifting purpose, manufacturing purpose, different application purpose. You can see the lathe machines are different machines also, so based on our motors. Rotation pulse, a winding machine. So winding machine also, you can see here coils how they are making, and you can see this the armature of with the induction motor. So they are going to wound the windings. How they are these windings wound? What are the different methods? Okay, you can see this one. Whether 2 poles or 4 poles or 6 poles. So based on our requirement, so we are going to manufacture different sizes of the motors. Okay, so how this winding takes place in industries? What are the basic things? How they are connecting the end coils? You can see everything is automatic. So these automatic machines are run by our electrical machines. Okay, let us see how these windings will takes place in our industry. How this fan owned with windings. Okay, so this is a DC fan. It has a commutator. Okay, So these are the slots you can see here. These are the winding coils. So how many number of turns? What is the pole pitch? This one. What is the back pitch? What is the front pitch? Some terminology we are going to learn in this class. Okay, here the brushes you can see. These are the normal machines. You can see this is a good example of our DC machine. As you know that this is a commutator. Okay, so this is a shaft. This is a armature. So armature consists of the armature core and armature winding. You can see, so this is the armature coils is placed in these slots and these slots. Now this is a one coil. We can see coil is nothing but consists of two conductors. This one conductor, this one conductor placed at a some distance, that is known as the one pole pitch. Okay, so we will see later in technology. This is the one armature used in our DC machines. Now you can see this is a big size DC machines. Have you observed in case of our traction system in railway system, the engines, electro locomotives, in that they have the six nearly the DC shunt or series motors. So you can see the size of these motors. This is the winding. This white color is the winding placed in the coils. And finally is connected to the commutator. So this is the one armature, big size armature. How this winding is wound? So why not is placed here? So instead of here placing, it can be placed here. So what is the rules and regulations? What are the terminology regarding to the winding? So we are going to learn in this class. Okay, so you can see. So you can see here, this is AC winding. So AC winding is a stator itself is a armature. Armature has the slots in which there is an insulating papers, PVC insulation, in which we are going to place the windings, and after that there is the insulators. Okay, how they are going to placed? What is the significance of the number of slots? So you can see this is the one coil. The coil consists of number of conductors, that is depend upon the rating of the machine. Okay, so he is manually is inserting the coils. You can see the coil pitch. You can the finished the armature of the AC machines. It may be synchronous machine or induction machine. Okay, stator is the stationary position, armature winding. Okay, inside there is the slots in which the winding is wound based on the some rules and regulations, lap winding and wave winding. Now in simple DC motor you can observe what is it consist. Here you can observe, dear students, this is a pole. In this case the poles, there is a two poles machine. P is equal, here the pole and pole shoe, and here the winding is wound. So this is a concentrated winding. Whereas in armature you can see armature has a slots, number of slots here, and coils are placed in a systematic way. So this is known as the distributed winding. Distributed winding. Here it establishes the magnetic field. Here also it establishes the magnetic field, but it's the uniformly distributed. It is connected to the commutator. Okay, so here the armature is placed in a some winding pitch and coil pitch. Each coil is placed and adjacent to the two poles or four poles or six poles, depend upon our requirement. As you know that the speed n is equal to, so his speed 120 f by p. If number of poles increases, then the speed of the machine decreases. Okay, two pole machine nearly 3000 rpm, whereas a four pole machine it may be automatically 1500 rpm. A six pole furthermore decreases. Okay, so you can see this one. This is the one good example of machine. It's the 4-pole machine. You can see here. So here the conductor slots, the rotor. Okay, this is a commutator, and the field winding is a phase of R phase. So you can see the north south 4-pole machine. And this is the armature. This is the stator. This is the rotor. Rotor consists of the armature winding, and these are the armature slots in which the winding is wound and is connected to the commutator. From the commutator, it is going to taken out from the carbon brushes out A and A. Similarly, the field winding we taken out F and FF. Okay, so the theoretical part already you know. So our aim is to know that how we are going to wound whether a DC winding or AC winding in armature. So before going to this one, so we should know some basics terminology regarding to the winding. Okay, let us first learn that thing. Our aim is to draw this diagram. So this diagram we have to draw it. Okay, so our aim is to draw this one. How we are going to draw this conductor to this one, this one, this one. How we are going to draw it, whether it is a lap winding or wave winding. What is the lap, what is the wave, we will see later. So if you this one, you can see here how the winding. If open this winding, for example, you take it. So this is the round. Actually, this is a physical. If it is a cutted one portion, if it is forcefully opened here, so we are going to get it is this one, similar to this one. Okay, so our aim is to, without any confusion, we have to draw this, whether it is a single layer or double layer, lap winding or wave winding. At the same time, the brush position also in case of DC machine. Sometimes we are going to equalize the rings in case of the DC also. So these are the basic things we should know. Okay, let us learn some terminology. If I having the one motor stator, for example, you can take it. Okay, so it has inside there is a number of slots. Okay, so the number of slots. This is the slots made in the armature. Okay, for example, this is the slots. Now I want to cut this portion. I can forcefully, this portion is removed here and this portion is moved this here. Then it becomes the just like is the, just you can see, and these are the slots. Okay, so these slots. In slots, I am going to insert winding. Okay, so I am going to insert winding. Here, it is similar to this winding that has the slots in which I am going to wound our winding coils. Okay, so based on this one, I open this one, and just like you are going to, for the easy understanding purpose, I am going to take this one. Okay, so here, so what is happened? I take the slots. This is the one slot, another slot, third slot, fourth, fifth, sixth, seventh, eighth. So these are the slots in which I am going to insert my coil sides. Okay, this is the slots in which I am going to insert my coils. Okay, this is the one, for example, copper coil. This is the one copper coil inserted in this one, and so we know that, so coil is nothing but, you can see this is a coil, this is a coil. So this coil may be having this coil side. So this is a coil side and here is a coil side. Okay, so I wrapped with help of my cotton tape. Then what will happen? So just like it appears as a one coil, this coil, but actually it is a number of conductors, whether it may be single conductor or multi conductors based on our requirement. So this is known as the one coil site. Here you can see this is the one coil site. Okay, so this one coil site is placed here, and the second coil site is placed nearby another slot here. Whether you are going to place here, or whether you are going to place here, or whether you are going to place here, that depends upon the some rules and regulations. Okay, so in this class we are going to learn that things. Okay, so now onwards, the machine which is having this round shape, so made it flat for easy understanding purpose, and here each slot consists of, whether it may be one coil side or two coils, that is a single layer. For example, this slot consists of here, so what is that one? Suppose this slot, so this is a, for example, slot. If this winding consists of only this coil side, one coil side, and each slot consists of only one coil side, then we can say this is known as the single layer winding, single layer. Or if you want to use it, suppose sometimes I can use the double layer also, this one. So at that condition I can use the one coil side here at this second. For example, you can take the, this is one. Okay, so this is a one coil and this is another coil side. Okay, this is a one conductor, this is another conductor, this is a end connection only. Okay, so this portion I inserted here. Okay, inserted here, and the second portion which is going to this one, I am going to place in the bottom of the nearby ear, in this case bottom. Okay, so that means here the coil side 1, coil side 2, one is placed here top and the second is placed in the bottom. Why? We will explain later. Okay, so you can take the another coil. For example, this coil may be consist of the one conductor. Suppose this is a single conductor, or sometimes already we know that, so this is a number of conductors, this one. So this is one coil side and this is another coil side. This coil side is the 1, this coil side is the placed in the 2 place. Okay, so this is known as the double layer. So this another coil will come here. So each slot consists of the 2 layers. This another one coil, and one coil first end and another coil second. This is one coil side, this is a conductor, this coil side 1 is this one and coil side 2 is this one. Similarly, so each slot consists of the 2 layers. So this is known as a double layer winder, whereas in this case only single coil side or conductor, then we can say the single layer. Okay, single layer. So you will give the, whether you are going to draw the single layer winding or double layer winding. Okay, that purpose I given the some idea. Okay, let us see. So what do you mean by the conductor? First of all, here the conductor means one copper wire. Okay, so one copper wire. So this is a, maybe this one copper wire. If this copper wires make it so this shape, it becomes to the coil. Okay, this is coil, it's a coil. This conductor make it as a coil. So that means here the active portion, this portion, this is the one conductor and this is the another conductor. So the conductor end points is connected here. So this we can say this is a coil. Coil is nothing but this is a coil. Coil consists of 2 conductors here. Okay, so number of coils indicated by the, so sometimes we can indicate it, so based on our requirement. Okay, the number of conductors is indicated with the Z. Okay, so we will see that later. So this coil sides, this is the just the conducting, this is the conductor, this is the conductor. That means, so conductors indicated by the conductors indicated by the Z. Conductor indicated by Z. So each coil consists of how many conductors? 2 conductors. So that is equal to, so number of conductors is equal to, so 2 into number of coils. Then we are going to calculate the number of, so whether we are going to single air winding, so then we are going to into multiply it with the 2. Okay, so that is the number of coils. Each coil consists of the 2 conductors. Okay, this coil, or we can say the slots also. Each slot consists single air winding. Each slot consists of 1 coil side. Okay, so this is the conductor. As you know, the conductor is a copper conductor or a aluminum conductor as per our requirement. Next, second one is the turn or loop. So turn, one turn, that means, so this is that one turn, or loop. Loop is nothing but this one. So for this one turn, suppose I am going to this one, so number of turns, this one. Okay, so 2 conductors lying within the magnetic field. So dear students, remember that this coil or loop placed this side at north pole, and subsequently this should be placed at the south pole. That is, one pole pitch is required. What is a pole pitch? We will see later. Okay, so here, so north pole and south pole poles. For example, you can the DC poles. Here is a 1 pole, 2nd pole, 3rd pole, and 4th pole. North, south, north, south. You can see this one. So this place to this place is the distance. This distance between the 2 consecutive poles is the pole pitch. Okay, so this distance between these 2 poles is a pole pitch. It's a pole pitch. Okay, for example, don't confuse. For example, if we take the here 1 pole, this is another pole, this is a north, this is a south, and what is the distance? So north to south, you can see the distance between this area is nearly 180 degrees. Okay, so distance between that means here the coil side is placed under the influence of these slots, and this coil side is placed corresponding to the same position of this one. So then it induces the EMF. So nearly one side is inducing the current this direction, another side is this direction. That is required. Okay, so that is the conductors lying within the magnetic fields. Now coming to the coil. The coil is nothing but this one. So this is the coil. Coil consists of the 2 ends, starting and ending. A coil may be consist of the single conductor or is similar to the multi-conductors. Okay, so more turns are connected in series, or 2 ends are adjacent commutator segments. So we are connected to the one segment and another segment. Segments we will see later. Okay, so this is the one thing. Now coming to the pole pitch. So already we know pitch. What is the pitch? P-I-C-H. Pitch means, so it is a football pitch or cricket pitch. For example, cricket pitch, you take it. So what is the cricket pitch? Pitch is nothing but distance. Whether it is a 4 or 6 runs, the distance from the player. Similarly, the pole pitch is the distance between the poles. Here, north pole and south pole, distance between the 2 poles, consecutive poles, that is known as the pole pitch. For example, if given the number of conductors, so we can the pole pitch is equal to number of conductors is given by number of poles. Then we are going to calculate the pole pitch. That means, so total conductors by how many conductors under one pole and remaining conductors under the another pole. So because we require the one direction is the upward, one direction is the downward. So that's because we are going to add the voltage. Each voltage produced in each coil is in additive. Okay, so already you know that basic things. Now here, for example, if we take the slots, suppose for example this is a one coil, one conductor, another conductor, another conductor, another conductor, another conductor, another conductor. For example, you take the one example here. So this each conductors, one conductor is connected, placed in the first slot, and it is connected to another slots, for example here. So this conductor. Now once again, if it comes to the back here, okay, then it is connected to here, and if it is connected to here and connected here, then here, that's connected to, it is a winding. For example, take it here. So here it is connected to the one commutator segments. This is commutator segment, another commutator segments. Okay, so another commutator segments, commutator segments, commutator segments, such a way that way. So here this is connected to here, and this is connected to here, and each, that means here it is connected, this coil is connected, this coil side is placed in the slot 1 and is connected to another slot. So nearby this, for example, it is placed in the 1, 2, 3, 4, 5, 6, 7, 8. So here the first coil, the coil 1 is placed in first slot, and a remaining portion of this coil side is placed in the 6th slot. Okay, now this is the active portion, this is the active portion. This is connected to the back side to this slot. So that is known as the, we can say the back pitch, back distance. It is the distance covered by the back end of the connections. So represented by the YB. Okay, so what is this one? It is a distance covered by the back end of the connections. Okay, this is known as the back pitch, YB. This is a, we can say from this place to and this place, we can say the YB, back pitch. Okay, now similarly after completion of this one, next it has to connect it to the this coil. So it has to come here. So here this is known as the front pitch. We can say this is the front pitch, YF. What is that one? It is the distance covered by the front end connections. So here front, we are connected to the front connections. So this is a back pitch, this is a front pitch. Now after front pitch, so it is connected to the second slot. Once again it is connected to the back pitch and placed in the 7th slot. After that it is coming to the next front pitch, it is placed in the 3rd slot. So this is known as a back pitch, this is known as the front pitch. Okay, already you learned in theoretical part. The commutator pitch, you can see the one example. This is the commutator. So what is the commutator? This first coil is placed here and second coil is placed here, third coil is placed here, consequently we are placing. The commutator pitch is the distance between the two commutators segments which contains two ends of the one coil. So this is, you can see that this is the one coil. For example, you can take the another color. So for example, so this, if we take this coil, so this is a coil. Okay, so this is a one coil I taken here, taken this coil. Okay, so the distance between the two commutator segments, I connected the one commutator segment here, and this coil, same coil is connected to the here. The distance between the two commutator segments which contains two ends of the one coil. This is one end, this is the another one. The distance between these two, distance between the this one. Okay, this is known as the YC commutator pitch. The distance between the two commutator segments which contains two ends of one coil, same coil. This is the first coil and second coil, and this distance between two. Okay, so these are the commutator pitch. Coming to the full pitch winding. Here the full pitch and short pitch coils also play an important role in winding. So in case of the, you can see here in AC, it is a for the production of the sinusoidal wave, so we require some short pitched coils also. So here, dear students, don't confuse here. So what is we have seen? So here the pitch is the distance between the two places. Okay, now here you can say the distance between the two adjacent poles. We have seen that pole pitch. The distance between the two adjacent poles, north pole and south pole, generally we taken as the total number of conductors by number of poles. We are going to get the pole pitch. So generally it is a 180 degrees electrical. At the same time, coil span also we have seen. What is the coil span? The coil distance between the two ends. The distance measured in terms of number of slots or number of conductors between the two sides of the coil, that is the coil span. At the same time, the coil span nearly equal to pole pitch. What is the pole pitch? So number of conductors per number of poles. Okay, so the coil span nearly equal to the pole pitch for the better EMF or torque in case of motors. If the coil span here, what is the, it is placed one coil side, number one slot, and another is placed in the sixth slot. Okay, sixth slot, first slot and second slot of the coil sides. This is the placed in the first slot, this is placed in the sixth slots. So that is the full pitched coils. So the coil span, so nearly the coil placed in, one is the north pole, another is the south pole under influence. The coil span is nearly equal to the pole pitch. So what is the pole pitch? Pole pitch is equal to number of conductors Z by number of poles. Okay, for better EMF purpose, so we are going to go into the full pitched coils, or in case of the generator, EMF is more and the torque in case of the motors. So now at the same time there is another thing, the winding pitch. So what is the winding pitch? So distance between the starting end of the two consecutive coils. You can see here. So here what is happened? So this is the one coil starting here, and next this is another coil, this is another coil. Okay, now this distance between these two coils is known as the winding pitch, YW. So distance between the starting ends of two consecutive coils. Okay, so it is connected here, it is a winding pitch. So because it's a winding pitch plays a vital role. So what is the purpose here? Let us see. Okay, so this coil is starting, this the coil is, what is the winding pitch of this one? So this is the winding pitch. Okay, now this winding pitch plays a vital role. So what is that one? So for example, winding pitch, okay, you can see here. If winding pitch is negative value. Then winding is known as a retrogressive. If winding pitch is positive, then we can use the progressive winding. Progressive winding. What is a progressive winding? Progressive winding. Retrogressive winding. Retrogressive winding. That means the winding which is, so here you can see first winding. So this winding is placed here and entered here, entered here, entered here, entered here, this one. Next is going to the coming this direction and is going to this one, entering, entering, entering and coming here. So next it is going to the this direction only. It's going to the this one. So that means it is going this direction. That is a progressive winding. So instead of this winding, suppose I place this winding. It is winding is connected here, here. So instead of going to this direction, you can see for example, so this coil, instead of this coil is coming here. So instead of going this one, if it is connected to this coil here. So instead of this one, if I connected this slot, this winding is connected to this slot, then so what will happen? It is moving this direction. Previously, so it is moving this direction. Now it is moving this direction. This winding is not connected here. It is connected to here, left side of this main coil. Next, it is connected to here. So what will happen? It is connected here. Next is going to this winding. That means it is a retrogressive winding. What is the progressive winding? A retrogressive. Progressive winding is moving this direction, so some left to right, and whereas the retrogressive is from the right to left. We will see later clearly. Okay. At the same time, the winding pitch plays a vital role if the winding pitch is greater than the pole pitch. If winding pitch is greater than the pole pitch, so that is Z by P. Then we can say this winding is a wave winding. And if the winding pitch is less than the Z by P, then we can say this is a lap winding. So there are the two windings, lap winding and wave windings. We will see those also. So at a glance you can see here lap winding means, now we have seen this one slot, 2, 3, 4, 5, 6, 7, 8, 9, 10 for example. Then I am going to connect this winding here. So from one, our coil is connected here and is placing for example here, and this end, this one coil side 1, coil side 2. Then if it is connected to the back here and is connected here, then it is connected here. Once I come to the front, it is going to the back and is coming to the front, connected here, connected here, connected here, connected here, then it is connected. That means it is just like it is a lap, overlap each other. That is known as the lap winding. Whereas in case of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for example, then what is happened here? So for example, I placed the one winding here and I placed here for example here. Then this is instead of coming this direction, I will go and this direction, then it is going to here. That means it is coming to nearly here, and okay, so nearly it will come to, so this direction is this one. Okay, so then once again it is going to the, so it is going the direction. Okay, just like you can see, this is a wave, this is a wave, next is a wave. That means you are going to get, sorry, that means here So all slots are wound. That means this is the wave. So wave winding. Okay, these are the lap winding. Overlap is this is a lap, overlap, lap winding. So lap winding are generally used for different applications. So where we require the more current is required, then we opt for lap winding. Whereas in this case, so we require where we require the more voltage is required, then we opt for the wave winding. Okay, so these are the some basic things already you known. So what is the difference between the wave winding and lap winding, and the number of parallel paths is equal to, in this case, so number of parallel paths A is equal to 2 in case of wave winding. Number of parallel paths is only 2 constant, whereas the lap winding number of parallel paths A is equal to number of poles. That's why here the number of parallel paths are more based on the number of poles, then current each path is added for the getting the more current. Whereas in this case, so here the only 2 parallel paths, and so the conductors are connected in series to get the more voltage. Okay, so this all are already you learn in theory part. Okay, so these are the some basic things, dear students. At the same time, I want to complete here. So what is that one? We stopped here. So first, okay, full pitch coil. So what is happened? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 11, 12. So these are the slots. Suppose conductors are taken conductors. Now so I placed the one conductor in this slot, and suppose YB is equal to 7. Then first slot plus it is going to the 8th. So you are going to the indicate this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 conductors. Okay, 12 slots I placed, each conductor one slot. Now so YB is 7, then we are going to get it 7 plus 1, that is the 8th slot I am going to connect. Here I am going to connect, this is the back pitch. Now it is connected here. Now YF is equal plus or minus 1, 5. Then it is going to the 8 minus, okay, that is 8 minus 5 is equal 3. So we are going to connect the, here I am going to connect the 3. Okay, so front pitch, back pitch. For example, I connect here. So as per our requirement, I connected here, here, and I am connected the here. Okay, now plus or minus 2. Now it is connected to the once again. So here there is a 3 plus 7. So I am going to connect the 10. Similar, this is a full pitch coil. This is a full pitch coil. As per YB, I connected the 8th slot. Suppose instead of I connected, so here same thing. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, so what is happened here? Suppose I place the okay. Now, so first slots I placed this one. Now, instead of placing the 8th slot, if I placed the only 7th slot here. So instead of here the coil is placed, instead of 8th I placed the only 7th slots. So this type of the winding is another short pitched coil. Short pitched coil. That means here the winding pitch is less than the pole pitch. So pole pitch is equal to 8th slot, but I placed the only 7th slot. So due to this, what will happen? The length of the winding is reduced. So I saved the some copper, but what will happen? Some there is benefits also. The good sinusoidal wave I am going to get it, and harmonics also be reduced. This is known as the short pitched coils. Okay, suppose if the winding pitch is greater than the pole pitch, then so instead of this one, if I connected, so another coil you can take it. Okay, this one. So what is the instead of this coil, this instead of this coil, I placed the ninth coil instead of, because eighth coil is this one, I placed the eighth coil. So eighth slots, I placed the eighth slots. So what is happened? This is a long, instead of 8 as per pole pitch, I placed the winding pitch is more than the pole pitch. So ninth slots I placed. So now in this case, the length of the back pitch is more and more wide I required. Then it is known as a long pitch. Okay, so there is a full pitched coils and coded winding or short pitched coils. So based on this one, winding pitch, so okay, winding pitch if so less than the pole pitch Z by P, then it is known as the short pitched coils, and if greater than, then it is known as the long pitched coils, Z by P. So this short pitched and long pitched coils. Okay, so these are the some basic ideas, dear students. And another is the resultant pitch. So resultant pitch, that is represented by the YR. So it is the distance between the beginning of the two consecutive coils. So already we have seen. So that means here, for example, you can see first this case, lap winding. Here it is started, this one coil, and another coil is started here. The distance between these two is known as the resultant pitch. Okay, so that means here you can see one, two, three, four, 5, 6, 7, 8, 9, 10. So here the one coil is placed here and connected to the some pole pitch here. This is a one slot. Next it is connected to the ear and connected to here. That means here in this case, so this is a one coil. Okay, this is a one coil. Okay, next, and this is another coil. Okay, this is another coil. Okay, now our aim is to the distance between this is starting and this is the starting. So the distance between the two consecutive coils starting, this is known as the resultant YR. The resultant pitch, it is a distance between the beginning of two consecutive coils, is known as the resultant pitch. Okay, so these are the things, dear students. Already we have seen single layer winding, in which, so what we have seen, single layer winding, the in slots use the only winding. Okay, so where, so here the single layer winding, in which one coil side is placed in each armature slot, is known as the single layer winding. Okay, single layer winding in which one coil side, so this one coil side placed in each armature slot, only one armature coil, this is a coil, then it is another single layer winding. Double layer winding, the two coil sides, this one and this one, two coil sides for slot are arranged in two layers winding or double layer winding. So here the another coil, this is another two coils, 1 2 1 2 two coils placed in each slot, that is the double layer winding. Usually one side of the every coil lies in the upper half of one slot and other side lies in the lower half of another slot at a distance of pole pitch. So this is already we have seen. So this is placed the top, another place is the bottom, or if you are placed in the bottom, another is placed the top. That is already you have seen. One side of the every coil lies in the upper half of one slot and other side lies in the lower half of the another slot at a pole pitch, that is the north pole south pole distance. Okay. At the same time, progressive winding also we have seen. If the difference between the back pitch YB minus front pitch is equal to, then the winding is progressive winding. Progressive winding means the winding is going here, is coming and it is going to this direction. So that means it is going to the left to right, it is going this direction, it is going to this direction. Okay, that is the progressive winding. So if retrogressive winding, so where so YF minus YB is equal to, then so it is going to the retrogressive winding. In this case, what will happen? In this case, so this winding, for example, it started here, it is going to this one and it is going to placed here. Okay, so now it is going to here and it is going to here. Next it is going to here and it is going to here. That means it is going to this direction. From starting to it is going to this direction. That is the retrogressive winding. So retrogressive, the difference between the YF minus YB is the 2. It is going from the right to left. Okay. So these are the some basic terminology used in our electrical winding, dear students. Okay. So another small topic, that is the multiplex windings. What do you mean by the multiplex winding? So let us see. This is the multiplex winding. Very easy. Multiplex. You know the multiplex theaters. So multi means more. For example, we can take one winding. So there is a one coil, this is another coil, this is another coil. The slots are connected such a way that one to this one. This is the commutator slots. This winding is connected here, and this winding and this one is connected here. Okay, this winding and this winding is connected here. Okay, so here what is happened? And this is this winding and this winding is connected this way. That means here is connected this winding and common terminal is going to this one, common terminal, and this is going to this one. This and here is connected this one. Here what is the slot 1, slot 2, slot 3. Okay, it is known as a simplex, simple winding. For example, in case of the duplex winding, duplex, the all parallel paths are single here. So duplex winding, what is happened? For example, coil 1, coil 2, coil 3, coil 4. Here slots also connected such a way that, okay, so here one slot. So this coil is connected here, and next is connected to this winding and slot is connected here. Okay, so now this is connected to this slot. You can see here what has happened. So this is connected to here. Instead of nearby coil, it is connected to this slot. So it is connected here, this slot. Next is connected to the next here. One gap is given. Okay. Now another coil here, you can see this is connected here, and it is connected to slot. Okay, so this is connected to here, and same time it is connected to here. Okay, so dear student, don't confuse. I am also some reason. Let us see. So here duplex winding. So duplex winding, it consists of the 4 windings. For example, this is a 1, this is a 2, this is a 3, this is a 4. Okay. Now I am going to connect it. So starting, I am going to connect here, and it's going to this one, this one. Now I can connect this to the second coil. So here I am going to connect this one slots, and this is connected here. Then it is going to this one. Next is I am going to connect this one to the fifth one, this one. Okay, so coil 1 and coil 3 is connected in series at a slots of 1, 3 and 5. Okay, so these slots. Next, whereas that means 2 simple lap windings are in parallel. So here is this is connected, a similar one, and same this connection I am going to connect with another color. Now this is connected here, and this connected here, and it is connected to center place here, and okay, so it is connected to 6th. That means you can see here this coil 3, 2 and coil 4 is connected here. Okay, that means here this slot here and this coil is here. So if this 1 and 2 are connected to parallel, take another. So this slots, the 1 and 2, one brush is connected. What will happen? Whatever the current is coming here, that is flowing through this one, at the same time it is also flowing through this one. That means it is connected. Now if I connected the another brush here, this here, so what is happen? So the current which is coming here and coming here, coming here, coming here, and coming this back from 5th slots. At the same time the current is also flowing and flowing and flowing and flowing 6 slots. That means this 1 and 3 and 2 and 4 coils are connected parallel. So this is collector plus, for example this connector minus. So this place, this is minus, brushes are placed. So this type of the windings are known as the duplex windings. 2 simple lap windings are in parallel each other. Okay, so don't confuse. Next, coming to the triplex or cortex. In triplex, 3 simple lap windings are connected in parallel. In quadruplex, so 4 simplex lap windings are connected in parallel. Okay, so let us see the one triplex. Triplex. What is a triplex? Triplex. So 3 simplex lap windings are connected in parallel. Okay, let us take the 6 coils here. So the coil 1, coil 2, coil 3, coil 4, coil 5, coil 6. Okay, so 1, 2, 3, 4, 5, 6 coils I taken. Now I will take the slots also. Okay, so here I taken the slots. Okay, so 1 2 3 4 5 6 7 8 9. So I can take the slots, this one, commutator segments. Now I connect. So first one coil, so one is connected here. Next it is connected to the, and that is the fourth coil. So 4 slots I am going to connect it, and here next is connected to the three is connect 7. Okay, so that means current is coming here, going here, and we are going to this one, and it's going coming out. It's coming, going. Okay, one path. Next we take the another path. In second coil we take it here, is connected to the second one, is connected to the fifth one, and fifth one is connected to the here fifth slots, and it is connected to the right here. That means whatever the current is coming here and going, and we are coming and going. So this is the end point, this is the starting point. Similarly you can take another blue color. So from third slot is connected here, and from third to it is connected to the sixth here, and is connected to the sixth one, connected to this one. Okay, so dear students, here you can see it. Now I am going to place the brushes, okay, brushes at this one. So if I place the brushes 1 2 3, 3 commutator segments is covered with help of my brushes, then what will happen? So whatever the current is entering, going this direction, going this direction, going this direction. And if I connected the here, so this ending points, 3 ending points, so brush position, what will happen? So it is the leaving. Okay, for example, this is positive, this is a negative. So such a parallel path, 3 simplex lap windings are in parallel connection. So this current, and so whatever the current induced, collected here. Okay, so this type of the winding is known as the triplex winding. Okay, triplex winding. Okay, this is a basic idea, no need to bother about it. Simply we have the single layer and double layer windings. Okay, so these are the basics, ideas, terminology regarding to our winding. Dear students, we will continue remaining part in the next class. Before that one, so what we have seen in this class, so in this class we have seen the general topics. What do you mean by the conductor? What do you mean by the turn or loop? So loop is nothing but it consists of the 2 conductors lying within a magnetic field of north pole and south pole. At the same time, coil also we have defined. The coil are more turns are connected in series, or 2 ends are connected adjacent commutator segments. And pole pitch is the number of conductors per pole, already we know. Back pitch is it is a distance covered by the back end connection of the winding. Front pitch is it is a distance covered by the front end connection of the winding. The commutator pitch is the distance between the two commutator segments which contains two ends of the same coil. Okay, so full pitch and short pitch also we have seen. A resultant pitch is the distance between the beginning of the two consecutive coils. Single layer winding is the in which one coil is placed in each armature slot, and double layer is the two coil sides per slot or arranged in two layer windings. Okay, so progressive windings is the if the difference between the back pitch and front pitch is 2, then winding is known as the progressive winding. YB minus YF is equal to, that is the winding is going from the left to right in progressive. Whereas so if the back pitch is greater than the front pitch, so front pitch is greater than the back pitch, there is a YF minus YB is equal to, then the winding is going from the left to right, that is known as a retrogressive winding. At the same time, lastly we have seen the multiplex winding, duplex winding. So two simple lap windings are connected in parallel, and triplex winding, three simple lap windings are connected in parallel, and quadruplex. So where in four simplex lap windings are connected in parallel, we have seen. Okay, so this is some part of the theoretical part of the winding. We will see remaining what is the lap winding, what is the wave winding, and clearly then we will draw the one winding. Okay, so thank you for listening my class, dear students.